So welcome everyone to the Master of Disaster Recovery Academy. So backup and recovery is one of the oldest and most frequently performed operations for any IT professional. Now, despite that long history, it still creates frustration and potential risk. So we believe we can improve on it a lot, not just a little, and part of that is going to be through education. That's kind of why you're here today. So this is part two of our Academy series, where we prepare you to handle some of the most difficult and potentially costly situations that companies are going to face today, which are data loss and downtime. So why are you really here? Well, that's because there's nothing more rewarding than seeing the look on a customer's face when you bring their server back to life, when you restore their data. You're going to see that look shortly after that deep, dark moment when it appears like all might be lost, and then you put them back into business. It's that moment of truth in which you've created a new level of trust with your partners. It's when you win a customer for life. It's the foundation of your reputation, and it's a story that people will tell about you. And as you know, word of mouth advertising, something you can't buy. So imagine this. Your phone rings and it's Bob the broker. Bob's got three employees in his financial services operation. Last year, Bob had transaction fees around £1 million, and his crew on average was paid around £150,000 each, which leaves Bob with a healthy £400,000 pound net income. Bob's business primarily runs on a SQL application. He uses it to track all of his customer information, their holdings, their trading history, their rates of return, production statements, etc. The server is truly required for Bob's business to operate. It's mission or business critical, if you will. So it's 9:30 in the morning, and we got Bob online, and his server's failed. So for him, it's a critical situation, and he wants us to bring him back into business. So if Bob had called you, and you were using our backup solution, what would you do? That's a question we're going to answer today. And when it comes to answering questions like that, we believe that seeing is believing. So we're going to take you through a couple sets of scenarios. They're going to apply one way or another to the typical type of disaster recovery environments or data recovery environments you're going to see with your customers. But before we do that, let's set Bob on hold and do some quick intros. My name is Eric Harless. I am a senior product manager here with SolarWinds MSP, formerly LogicNow, and I've dedicated the last 20 years of my career to backup and disaster recovery. So I've worked with companies such as Veritas, Symantec, Commvault, ArcServe, FalconStor, LogicNow, and of course now through the acquisition or merger, part of SolarWinds MSP. Now, speaking of Bob or customers for that matter, you really never know when that call is going to come in. Odds are, while you're on this webinar today, you may have a customer call, and obviously you've got other technicians and other individuals in your organization that can take that call, but occasionally you get pulled away when you least expect it. So the key thing here is when that call does come in, you want to make sure that you're ready. Today we're going to go through a few scenarios, as I said, that we really want you to be prepared for. We want you to have the trust and the confidence that you can deliver on the expectations you've set when you sold the backup and recovery solution to your customers. We want you to know that it's going to be fast, simple, and predictable when you need to recover. So specifically, we'll go through scenarios such as failing over to a standby server, failing back using our bare metal recovery technology, recovering files while working remotely, and then finally recovering or rolling back a corrupted or damaged database. Now, before we go any further, I'm going to pause for just a moment, remind you that I can pretty much guarantee without a good backup in place, you're not going to have a very good restore experience. So the good news here is that with the Max Backup, or I guess the MSP backup and recovery product, the process is fully automated. It comes with some really strong monitoring. So once you've set this up, configured it for your backups, really all you need to go do is go back and monitor your solution to ensure you've got good backups in place. The last thing you want to do is find out when the customer calls that, hey, wait a minute, we haven't had a good backup in the last 3 days or the last 3 weeks due to some software installation or configuration error or system being offline. So if we go back and look at what we learned in part one of the Backup Academy, we'll do a quick review of our 3-2-1 backup strategy. This is at the core of what we provide. It's a commonly accepted best practice in the backup industry. With the 3-2-1 strategy, we always maintain a minimum of 3 copies of the data. So that's 1 production copy and at least 2 backup copies, although you could maintain more. Secondly, the backups are maintained on 2 different types of media. And then finally, at least 1 backup copy is always off-site. Now, for those of you that are new to the Max Backup or MSP Backup platform, we've been in business since 2004. We work with over 7,500 resellers worldwide. We operate storage out of 7 global data centers. We've got single customers out there as large as 5 petabytes, that's with a P. Thousands of customers in that 10 to 300, 400, 500 server type space. Single servers as large as 40 terabytes under management. We successfully complete over 50 million backups per year. Combine that with a fully featured, highly reliable platform, a simple pricing model, 24/7 phone support, and we believe you've got a platform in which you can build your business and in which you can trust. That's enough about us, though. Enough with the slides here. I want to get back into the scenarios. So remember Bob? We got Bob on hold, and he wants us to get his server back up and running. So let's do what we need to do to get that system going. Now, the nice thing with Bob here is that we've got a plan in place. We've established what we need to do in the event of an outage. So here we're going to go through those motions to get Bob back up and running and show you just how quick and easy it is to do that when a customer calls with the right upfront planning. So first thing we're going to do is we're going to remote into Bob's infrastructure here. So whether we open up a remote desktop or a VPN connection, what I want to do is I want to bring up Bob's Hyper-V server. This Hyper-V server is a standby appliance or a standby server in his organization designed specifically for business continuity. So if I go into this system here, I can select this Windows 2012 R2 system, and I can start that machine, and then I can connect to it. So what we've got here is effectively a mirror, if you will, or a standby instance of Bob's production server. Each day as we're doing the backups, in the background I am continuously virtualizing that backup data to a virtual machine. This means that within a few minutes of a backup completing and synchronizing up to the cloud, I'll start to perform a delta restore of that backup data to an offline virtual machine. In this case, a VHD file, although I can go to VMware, Hyper-V, Azure as well. So this means that business continuity is as simple as starting up a virtual machine and then assisting Bob to connect to that machine, whether it be inside of his organization or maybe residing out on a public or remote data center. Now, that technology is brought to us by the virtual disaster recovery feature inside of Max Backup and inside of our recovery console. This allows me to recover anything from a Windows Vista, Windows 7, Windows 8, Windows 10 workstation, or Server 2008 through 2012 R2, Windows Server OS to the hypervisor platform of my choice. That could be a VMware ESX server 4.1 through 6. We are currently developing our VMware 6.5 support, and would expect to see that out in Q1. Additionally, I can create just a flat VMDK file that I could then sneakernet over to a VMware workstation, a VMware player, or inject into the hypervisor instance that I have in another location. For Hyper-V environments, I can create that same kind of offline VHD or VHDX file, or I can inject it directly into a Hyper-V 2008, 2008 R2, 2012 or 2012 R2 Hyper-V environment, typically your version 2, version 3 hypervisors. If you don't have a VMware Hyper-V environment or a virtualization infrastructure that's available to you, we can support the Microsoft Azure or the Amazon EC2 Cloud within limitation. Those type of platforms have a little bit more complex management environments. They are bring your own credential type clouds, so you would create your own account, have your own payment and login information for those portals, and also you want to be aware that those environments have different limitations on the OSs they can support, sizes of volumes, types of configurations around GPT partitions and UEFI BIOS, etc. So if you do decide to choose public clouds as your target, just research those limitations before you have a customer call looking to be spun up in a DR site. Now, with Bob, as I said, seeing is believing. So if we review what we did there, we turned on a standby server. We let Bob connect to it. We had him back in business in less than 5 minutes. We made it look easy. That's because it is. There's nothing hard with turning on a VM, playing around inside of a virtual infrastructure. technically not that difficult. Any one of your technicians that's touched a virtual environment once could do that. The fact that we made it look easy, though, wasn't because of what we did today. It's because of what we did before today in order to be prepared for it. So truly, providing a customer with the right experience is about planning, planning, preparing, and testing. So when it comes, that it's just a few clicks to get them up and running. It truly is a case where failing to plan is a plan to fail. You don't want to try to figure out how to get an Azure account after the customer calls with an outage. You don't want to try to figure out how to stand up a VMware or Hyper-V environment at your facility to help assist in a restore while the customer's looking over your shoulder and experiencing downtime. So I do encourage you to go out in your trial environments, your production environments with our backup product and evaluate our recovery console, our virtual disaster recovery technology. Build some standby virtual machines, even if they're workstations. Windows 7, Windows 10, you want to use the hypervisor role in Windows 10 Professional. Feel free to do that. We'll support it. You want to work with Oracle VirtualBox or VMware Player, then create those offline VMDK files or VHD files and import them into those tools. All those environments are going to be great experiences for you in helping to provide business continuity and get a customer up and running quickly at his location inside of your data center or possibly inside of the public cloud. So as I mentioned, planning, preparing, and testing, the first thing that went into planning here was setting the proper expectations with the customer. So we spoke to Bob, and we helped jointly determine, based on his business requirements and his budget, what was available to him for disaster recovery and business continuity. So Bob determined that he didn't want to be down for more than an hour under any circumstance, assuming that he still had access to his facility and his network. In the case that the network or facility was not available, then he was comfortable with failing over to a cloud location and having up to 4 hours of downtime maximum. So based on that, we created a plan, actually 2 plans, and with those plans, we made sure we allowed ourselves a bit of wiggle room, just in case we needed it. So in this example, we brought Bob up by starting a VM in under 5 minutes. Now, even though the expectation was an hour, we over-delivered and under-promised. So that benefit here is going to allow you to have some flexibility when managing multiple customers, when having resource limitations with your technicians, managing priorities, or when you get that call after hours and it's now an hour drive into your office, or finding a facility where you can get online to access your systems and trigger those failovers for your customer. So you want to make sure that you don't overpromise and underdeliver. That's just going to set a bad expectation for you and your customer. Now, what are the actions that we had to do to prepare for the moment? Well, first thing we did is we installed the Backup Manager on the production server. Anybody that's in trial or in production now, you've probably done that already, but it's also about making sure you've got the right data selected so that you can recover that entire system in the event of a data loss. So as a minimum, the requirements for any full system recovery are going to be to select the system state and the system drives. Those 2 components are what allow us to synthesize a virtual machine in the background as part of the virtual disaster recovery process. Now, any application-specific plugins like SQL or Exchange or SharePoint, you'll also want to select those to ensure that you've got applications consistent backups for that data. Obviously, if you don't protect it, it can't recover it, but at the bare minimum, to create a virtual machine, the minimum requirements are going to be file system plus system state. File system only, you can't have a bootable machine. System state only, you don't have your data. And of course, if you don't select SQL or Exchange or your network share environment for the critical user shares, then even though you've recovered the machine, you're not going to have the data that you're looking to recover that machine originally hosted. So set your selections very carefully. Now, secondly, we installed a component called the Recovery Console, and we installed that on a local standby server. In this case, it was a Hyper-V server at Bob's primary location. We set that up to do continuous virtualization of his production server in the background. That means that within 5 minutes of any backup completing and synchronizing to the cloud, that standby server will get updated with the Delta or the latest changes, and that's what enabled that 5-minute failover that you saw a few minutes ago. So third, because Bob wanted an off-site failover as well, we set up that same configuration, a recovery console, at a cloud continuity location. This could be a virtual server at the MSP. It could be a public cloud option such as Amazon or Azure, or a secondary office that Bob or your customer might maintain, whether it be an actual branch office or even just a home office, someplace where they can have another server running with sufficient bandwidth in order to pull down those delta changes. So given all of that, let me show you quickly what that recovery console looks like. And now this recovery console is really the best tool for providing business continuity. So when we open up Bob's hypervisor here, and we'll give me a second for this to connect. So when we open up Bob's hypervisor here, you can see on the desktop we've got an icon for the recovery console. I've got a running instance in my taskbar down here. We'll bring that up. The recovery console is going to sit here in the background. You can see it's got two devices configured for continuous restore. The Windows 2012 server we just booted. You can see I've got restore history here for that machine, which is going to happen shortly after each of those nightly backups that I talked about. If I go in and reconfigure or edit the configuration for that device, you can see that it's configured to perform virtual disaster recovery, which is one of the types of restores you can perform with this console. Now, once you go into the console here, you can select your restore target. For virtual disaster recovery, you're going to pick the hypervisor of your choice, whether it be those offline virtual disk files or an active local hypervisor or a public cloud hypervisor. And you'll be presented with various settings here now, depending on the type of hypervisor you choose, to control restore settings, login information, the name, and the network configuration for that virtual machine. Very, very similar settings to what you would have inside of the hypervisor itself if you were setting up a new VM for a customer. Now, as I said, that recovery console is your best tool for providing business continuity to a customer. All of the tools that we offer have got restore capabilities, but a lot of those are reactive restores, meaning you wait till the customer has a data loss or an outage before you would actually trigger a restore. With the recovery console, you can set it up to be proactively creating and updating that virtual machine in the background so that you have a standby server waiting for you in the event of an outage. It's a little bit more costly from a resources and hardware, time, bandwidth perspective, but it provides that extra assurance that in the event that the system is lost, I can be up and running in the shortest amount of time possible. Now, this recovery console, as I said, provides that continuous virtualization. It can be used for one or more devices simultaneously. It allows not only continuous restores, but on-demand restores. So assuming you did not want to have a standby server sitting there for a customer, maybe they didn't buy into the whole idea of paying you for a recovery machine to sit there waiting. But then they have an outage and they realize they don't have replacement hardware. It's going to take 3 days due to holidays before they can have the hardware in-house. They may call you and say, hey, what can you do for me here? And you've still got the option reactively, if you've selected the right data for protection, to synthesize that virtual machine reactively or post data loss. We can run this recovery console on anything from Windows 7 through Windows 10 workstation. You can run it on a Server 2008 R2, a 2012 or 2012 R2 system. The key here is really to be running the recovery console on the same OS or newer OS than the OSs you're looking to recover. So if you're trying to recover the full gambit of Windows Vista through Server 2012, I'm going to recommend you run the recovery console on a 2012 R2 machine to ensure the highest level of compatibility with things like GPT partitions, UEFI BIOS, the latest VHDX format if you're going to go Hyper-V. If you're going to be pushing this out to VMware, you want to make sure that the version of VMware you're pushing to is at least the same or newer than the versions that you're coming from. If you're going to be going from ESX to ESX recovery, or you want to create a VMDK file and import it into a hypervisor. But play around here a little bit. Do some experimentation. As I suggested, recover a couple laptops, a couple workstations. Back them up for a little while, recover them to a virtual environment, boot them up, get yourself familiar with the experience so that when a system does fail, it's not the first time that you've experienced that user interface. Now, before you can receive a call from somebody like Bob and feel safe that you're going to be able to get him back up and running, it's important that you prepare for that event, and it's going to be through testing, as I suggested. So whether you're testing, just spot checking inside of your environment, or possibly you're going to build testing into the service you provide your customers, either way, it's going to provide that confidence that you can deliver on the expectations you set when you sold the solution to your customer. So disaster recovery testing is a real value. It's something you can sell. It's something you can use to strengthen the relationship with your customer. So in Bob's case, we wanted to have both local disaster recovery and offsite disaster recovery. So what we set up is the recovery console on the right at two different locations, one local and one remote. We did the continuous virtualization using the recovery console from the production system to those machines. Now, to test, I can do this as simply as shutting down the production machine and letting them fail over to the recovery environments, but that's disruptive. And not all customers want to have a disruptive disaster recovery event monthly or even annually. So we can do this also non-disruptively. So I can do automated disaster recovery testing in the background where I'll boot the VMs behind the scenes, take a screenshot, and send that screenshot to you as proof of performance. The key thing, or you can do these testing manually. Make sure you're running these VMs behind a NAT in their own subnet, behind a firewall, on a VLAN. That way you don't bring down your production environment by starting up another Exchange server or domain controller. But get your customer involved. Who's going to know their environment better than they do to see how the latency and the performance is in this DR environment? That way they can really determine, can I actually run in this virtual environment for 3 days or 5 days while we're working on having the hardware repaired. Now, we navigated that situation. You know, the emergency happened. We failed over. We got Bob up and running. Now that's great, and maybe you own the break fix for these devices. Maybe you don't. But at some point, that hardware is going to be repaired or replaced, unless they decide to stay virtual. And in that situation, you're going to need a plan to get back from the virtual environment that you've ran on for the last 3 hours or 3 days, and probably performed backups. You'll need to get back to the physical environment once it's been replaced or repaired. So to do that, we can utilize our bare metal recovery technology. So bare metal recovery at the highest level is a Windows PE operating system with a very light version of our backup manager software. We allow you to create boot media either in a USB boot stick or an ISO image that you can burn to CD. You'll boot into this light version of Windows, Windows PE. You'll use it to recover either selective volumes or selective data or the entire environment. And then you're going to go through a first reboot. First reboot is very important because you want to make sure that you've timed it properly so that you can fail your customer back to the physical hardware as opposed to staying on the virtual configuration. So to start, we will download the bare metal recovery tool. In this case, we'll use the executable to create a USB memory stick. Typically, I'm going to recommend between 8 to 16 gigs on your memory stick here. We do format that memory stick, so we're going to make sure there's nothing important on there. When we launch the executable, it's going to ask you to specify the drive letter of the USB media. And as I said, it does format that media. The next option is going to be to include additional drivers on that media during creation. This allows me to specify on the local machine the INF files for various drivers that may not exist inside of Windows PE. It might be a Windows NIC, like an Intel or a Broadcom NIC driver, a video controller driver, a RAID controller, RAID storage controller, things like that that don't exist inside of Windows PE. But you'll see that very quickly when you boot up. If you don't see your disk or your network resources, you'll know to add those. Now, during the boot process, we'll configure our network settings. You can set up a static or dynamic IP address. You can specify a temporary network storage path to store the backup register and the log files. And this is very important if you're booting with the ISO image because you don't have write access to that CD, obviously. It's going to prompt you to enter the credentials for the system you're recovering, in this case the device name and the password, as well as the encryption key. Now this security code was a code that you created during your initial deployment of the backup manager. It's something that you should have written down. You need to log that and retain that in a secure place. Without that security code or that encryption key, we cannot recover your data. So you want to make sure you have access to that. Now if we look at the summary here, you can see that we've got backup sessions that are available for restore. That's great. We're going to go to our Preferences tab and check our local speed vault. As you learned in the Backup Academy, the local speed vault is a mirror of my cloud storage, or it strives to be a mirror of my cloud storage. By having a local speed vault configured on my local network, I can do my bare metal recovery in a fraction of the time it would take to pull the data from the cloud. So you might be talking about a 3-hour restore here versus a 24-hour restore, depending on network connections, and of course your customer's available bandwidth. Now I've dropped to a command prompt here, and I'm looking at disk part. This is going to allow me to look at the disk configuration. So what I've done here is I've actually cleaned those disk partitions, so that way we'll no smoke and mirrors here. We are going to recover the full volumes. I'm going to select a session here to restore. We'll choose the volumes we want to recover. Now, if I only want to recover the boot volume, I can select C only, but in this case, I want to recover all volumes. And then I'll kick off this restore. Now, from this point forward, once I kick the restore off, I'm going to do a little bit of industrial light and magics here. I'm going to do a time lapse. So what you're going to see at this point now is this restore happening. It should take about 30 minutes or so for the restore to complete, but we're going to time lapse this down to about another minute or so. That way you can see the full process on your screen, but we can move on to other scenarios that you'll want to deal with. The recovery process here, once it completes, we'll take a look at some of our log files and session files so you can see some more detail. It's going to want you to remove your USB key and reboot the system, but before we do that, let's look and see what we actually recovered. So if we go down and look at my session history here in the calendar, you can see 32 gigabytes, 22 minutes for the restore. If I go to a command prompt, just one more second. If we go to command prompt, you can see here that I've got data on volume C, I've got data on volume D, and I've got data on volume E. Now you might ask, I only restored C and E, why do I have 3 volumes here? And that's because Windows typically has hidden system partitions as well. So we did recover those. Those have drive letters assigned at the moment. That drive letter will get reassigned as a hidden partition upon this first reboot that you're seeing now. This is going to allow us to boot into that recovered server. So here's my Windows 2012 coming up. It thinks there was an improper shutdown because of backup happening in the middle of the day. I'll just tell it was a bare metal restore and that it was successful. Now I've got the option of opening my backup manager. You can see the backup manager is up and running, but it's in restore only mode. This is going to prevent backups from happening on this machine until I'm ready to push it into production. So it's very key that you time the bringing up of this system with the shutdown and decommissioning of that virtual machine that Bob's been using. So we'll put this into production here so that we can start doing backups and configuring and make sure things are going to work. But more importantly, the way you're going to want to time this is to ensure you don't create downtime for your customer. So ideally what you might want to do here is perform this bare metal recovery. Shut the system down, don't do your reboot yet, do one final backup then of the virtual environment that Bob's up and running in to get those delta changes. As soon as that backup completes in 5 minutes or 15 minutes, whatever it takes, shut down that virtual machine as soon as it completes the backup process. Then boot your bare metal recovery environment that you just restored, and then go into production mode, perform one final restore, and that will give you those delta changes that you just backed up. This is going to allow you to make sure that you've got zero data loss between switching over from the virtual back to the physical, and it'll give you the shortest possible amount of downtime. And ideally, you're going to do this over a weekend, over a holiday, in the evening, in the morning before the customer comes into the office. The last thing you want is Bob sitting over your shoulder while you're working on this recovery. You just want to complete the recovery and then leave a voicemail or an email for him, letting him know that when he comes in the office on Monday, he's going to be working back on his production hardware. No reason to let data loss and downtime of your customer create data loss and stressful recovery situations for you inside of your organization. So what you saw there was bare metal recovery. And we created a bootable USB stick. Obviously, I could have burned an ISO to CD. It's a bootable Windows PE environment that I mentioned a few times. WinPE has most of the drivers you're going to need for booting up a system and connecting to its disk structure and its network. However, if it does not, newer hardware, server hardware that wasn't designed to work with Windows PE, things like that, you can inject those drivers. The only real requests I've seen for driver injection have going to be, like I said, been the occasional Intel NIC or Broadcom driver, maybe a RAID storage controller if it's not handled as part of the BIOS in the boot. We can recover to both similar and dissimilar hardware environments or disk sizes and structures within limits, obviously. We do support BIOS, UEFI, MBR, and GPT partition structures. We support the following modern operating systems. That's Windows Vista through Windows 10, Server 2008 through 2012 R2. the key thing to note here is that when you're dealing with dissimilar hardware environments or different configurations like a BIOS versus UEFI or MBR and GPT partitions, I don't convert between them. So if your original system you protected was a 2008 R2 system that was BIOS MBR configuration, if you bring it to new hardware that's UEFI and GPT partition capable, it needs to have legacy mode support as well. I can't change the way the operating system is deployed and configured, and the partitions are configured on the fly. It's just going to break your operating system. So those are more candidates for data migration or a manual disaster recovery, where you would install a new OS on the new hardware and configure it the way you want it to be, install your applications, and then restore your application data only. But either way is something you could do with our backup solution. So you saw failover, you saw failback with bare metal recovery, and that's great. And if all of your disaster recoveries are full system losses, those are all the tools you need. If all you have is a hammer, all your problems look like nails. But in reality, all data loss events are not the same. But there's some backup products out there in the market that they do virtualization, they do full image backup, and that's all you're presented with for your restore, and you're kind of stuck dealing with this image level backup just to get back files and folders or applications. So what I want to do is I want to talk a little bit about the types of data loss, who's the real enemy here, and then choosing the right type of data recovery environment for the data loss. And not, of course, to underestimate these data loss events. So we believe that there's broken into three categories here: acts of nature, acts of hardware and software, and then finally acts of people. Your acts of nature are going to be your fire, flood, tsunami, volcano, hurricane, tornadoes. But more importantly, it's going to be the associated power and service outages related to those natural disasters. So even though they don't happen very often, when they do, they could be very, very serious. They could have the longest potential impact or potential downtime, and they could impact your entire site or your entire region. So for that simple fact alone, you're not hit by the fire, flood, or tsunami, but you have no electric, no power, no network, or your employees can't even get into the office. Those are all potentially reasons why you're impacted, even though you didn't physically lose a server. The second group is acts of hardware and software, and I've been told there's really just two types of hard drives out there: those that have failed and those that are going to fail. So if you work on this, off of this assumption, at some point you're going to be faced with a situation like Bob had today, where he had two hard drives in his disk array fail simultaneously, and he lost the array, and that caused his downtime. You figure hard drives are created in batches that can have manufacturing defects. The serial numbers were 1 digit apart, and they both failed within a matter of a few minutes, and there was your data loss. So even with things like RAID, with clustering, with redundant NICs and redundant power supplies, you can still have data loss and outage that requires failover to a virtual environment or failover or bare metal recovery back to physical hardware. Finally, we've got the acts of people, and acts of people are going to be people doing things they shouldn't do, whether it's intentional or unintentionally. They're deleting things. It's theft. It's hacking. It's sabotage. It's ransomware. Flavor of the day, flavor of the week, if you will. People are going to open attachments. They are going to click on links. Now, you combine that with a missed patch, a missed service patch update. Somebody's addressing their personal email on a work server. They're going to find a way, the bad guys are going to find a way to get in. I guarantee, no matter how much training you do internally, no matter how much software you deploy, somebody is going to see a big red button like this and go, wow, what happens if I press it? And as soon as they do, you get a situation like this where the bad guys have, like I said, have found a way in. Now, hopefully, all you get is a CryptoLocker 2.0. Maybe that's something you can recover from now. There's been great strides in recovering from ransomware and decrypting what they thought was once undecryptable. However, that's not always the case. So, when you see this in your environment, your last best effort is going to be to recover from a backup. Now, with that said, don't immediately purge the machine. Don't immediately run antivirus software and start cleaning and deleting files. you want to sit back. You want to isolate this guy from the network. You want to do some triage here and determine exactly the best effort. You want to go look at your backup history. You want to make sure that you've got backups for this machine of the right data. Now, once you've confirmed that, maybe you do want to restore back over top of this original machine. But ideally, I'd recommend you virtualize or you restore back to a network share or another location. Confirm that you've got the data that you think you have. You don't want to delete this system and then realize, hey, wait a minute, I'm missing some of the data, or my backups are 3 days old, but I need data from yesterday. I'm not recommending you pay the ransom, but ultimately it is your customer's data, and you need to present them with the facts and let them make the determination of, do they need to pay the ransom in order to stay in business, or can they deal with what happens to exist on the backup tapes or in the cloud. So as I mentioned, not everything is a candidate for failover and failback. Failover should be a last resort. It's not a bad resort, but it should be a last resort. Things such as acts of people don't always require a failover, at least as long as you're using really good software and we've got plenty of recovery options. So choose the recovery option that is most appropriate for the data loss you've suffered, and that will get the customer back up and running within their SLA, within their recovery time objective. So the next couple scenarios I have, we're going to talk more toward those more common recovery type of scenarios. So let's go back to Bob. So imagine this. It's now 11:40 a.m. It's about 2 hours since we originally saved Bob, and he's left the office a little bit early just before lunch to get to an important lunch meeting. He's meeting with a new prospect, and he's hoping to land this new client. He'll be meeting with him in about 15 minutes, but Bob's sitting at the table. He's going through his laptop. He's connected back to the office, and he's discovered that there's a bunch of statistical data, specifically 20,000 small files, that he was going to be utilizing alongside his presentation to demonstrate what he needed for this particular prospect or customer. He's calling me from his cell phone, and he's hoping that I can help him find that data and get it back accessible before his meeting kicks off. So that's the first problem. He's not on site. We got to get some data back. Second problem is I'm not at my site either. I've stepped out of the office, so I'm on the train heading to an appointment with limited cell and or Wi-Fi connectivity. Maybe I've got a laptop, maybe I've got a large iPhone, maybe I've got a small tablet that I can work with, but I don't have my NOC. I don't have my multi-screen configuration in front of me with all my applications pre-installed. I don't have high bandwidth to do a lot of things right now. I'm working in a very limited environment. Secondly, maybe I'm sitting at the dentist office waiting for that root canal that I've been putting off for the last 6 months, or I'm at my daughter's third grade recital, and that's going to be kicking off in a few minutes. All of those are real possibilities. You never know where you're going to be when a customer calls, or if you're going to have access to internet or the tools that you need in order to help get them back up and running. So we'll just demonstrate this from two different angles. So we're going to start out by remoting back into Bob's environment. So this is the same Hyper-V environment you've seen a couple times now. We'll open up his virtual machine. So in this environment, you can see I've got on the desktop here this folder called 20K. This folder has inside of it, you have to bear with me here, looks like a little bit of technical difficulty. Let me restart that here. Bear with me. Okay, so we'll get back into the Hyper-V environment and open up Bob's virtual machine. So the first thing we're going to want to look at here is the 20K folder. So this folder on the desktop has got 20,000 small files inside of it. It's 1,000 files per folder, 20 folders. Now, if you look at these are just text documents. They're 1K a piece. There's about 10 megs worth of data here. This is not a large data file. It's just a large number of files, which is typically something that backup applications have a hard time with. So I didn't want to bog this down with a large amount of data, just a large number of files to show you the efficiency of processing. And then, of course, we can recreate this in just about any environment for you to test out with your own bandwidth and in your own configurations. But just the act of dragging this to the recycle bin and then emptying that recycle bin is going to take a few moments. So the Windows operating system handling this number of files is not the quickest. It's not like deleting a single 10 meg or 10 gig file. There's some processing involved in the background as it's doing this. So once these guys are gone, let's open up a browser. So I'm going to open up Chrome over here on this other system or this other environment, and I'm going to do everything from a recovery perspective exclusively inside of a browser here. So I've opened up Chrome and I've navigated out to backup.management. This is a web-based version of our management console. I'm going to log in using the same credentials that I have for my standalone cloud management console for backup. Once I get into here, I can see at a glance that I've got 6 servers and workstations under management for Bob's account. I can see the backup history here to see successes and failures. I can click on the pie chart and drill down into those successes and failures if I need to. But specifically, I want to look at Bob's Windows 2012 machine here. I want to see that I've got successful backups that have been happening for it, both for the file system, for system state, and for SQL. And I'm going to launch the backup client. Now you'll note I've not installed any software here. I'm working exclusively inside of Chrome. I've now managed to connect to Bob's Backup Manager remotely. I'll go to the Restore tab. I'm going to use the most recent session. I'm going to go down and expand the file tree. And I'll go down to Users. I'll go down to Administrator. Let's see, I want to go to my desktop. Where is it? There it is. And I'm going to select this folder 20K. So I'm going to click that and hit Restore and tell it to overwrite those files if they already exist. And that restore process is going to kick off. Now, depending on whether this data is stored exclusively in the cloud or stored a combination of the cloud and that local speed vault, you'll see different processing and speed times. But as I said, not a large size, just a large number of files. Identified 20,000 files to restore. It's already started processing those files. That's great. If I look back at the production system here, the folder's already been recreated. There is some data inside of this. It's not the full size, but there is some data already back. If I go back over to my browser, I can see that now we're finalizing the restore. We'll give that just another moment to complete. There we go, restore completed. Now, if we look back at Bob's server here, and we hit properties, we can see that 20,000 files, 20 folders, about 10 megs of data. That's all back. That's great. We can close this virtual machine now. And if you look at my log history here, I restored 20,000 files in under a minute. So the key thing here to realize, it took less time to recover the data than it did actually delete it from the recycle bin. But you know, what you're looking at here, this is a representative set of data. What I encourage you to do is to understand your customer's bandwidth, understand how much data you might be looking to recover if you had to bring back a customer's user folder or the network share, and then of course understand what kind of bandwidth those customers have. Depending on what that is, it may warrant that local speed vault at the customer site versus just cloud backup. And we give you this hybrid data protection capability at no additional charge. Why not utilize it? You know, having a additional NAS device or USB hard drive or second drive inside of the machine at the customer premise provides some stickiness. It provides that quicker recovery. It's going to get you out of a bind if the customer needs the data back and needs it back now versus waiting for it to recover over a slow internet connection. So things to think about, and I definitely encourage you to grab your own representative data set and you know, test that out in your configurations and your environments, so you can understand just how quickly you can get the data back for your customer. That might determine whether you restore the data at your premise and then physically deliver it to your customer versus recovering it at your customer site remotely. So when the call comes, obviously we've got to be ready, and you know, we save the day again here for Bob. But the bottom line is that if you're not ready, you're not going to keep that customer. So the 3 takeaways from the incident: you got to be ready. So having a good backup in place is required. It's kind of obvious, but if the backup wasn't good, then I wouldn't have been recovering the most recent data or any data possibly. And you know, the nice thing here though, reliable backup software, good monitoring, you can see exactly where those failures are if you're having them, and you can work to address them proactively, manage by exception. You just need to make sure that you're looking at our management console or monitoring the emails that we send out on a regular basis. I understand you've got other jobs and other tasks and other customers, so you can't devote your entire day to managing and monitoring the backup operations, but you do need to devote some time on a regular basis to monitor those and to take action on systems that have exceptions, failures, certain files that can't be backed up, what have you. Now, secondly, speed matters. If this had taken an hour and 45 minutes to recover the data, how would that have impacted your customer? Well, Bob would have not had a successful lunch meeting. He may not have won that customer. If Bob had lost a customer, could he afford to pay your bill? Would you keep Bob as a customer? So if your customers get fired, sometimes you get fired. And then, of course, that means we get fired. So we really want you to have the best tools available for you and the ability to recover in the quickest possible manner. Now, the reason I suggest an hour and 45 here is I actually took the same data set, the 20,000 small files, backed it up through a third-party cloud-only provider, and then it went back to do a restore using the same system, same data, same bandwidth, and it took an hour and 45 minutes to get that data back. Not because of the size, but because of the number of files and the manipulation. Now, I'm hoping those were the two extremes. The only thing I can think of that might take longer to get the data back would be if you were still using tape and you had a secretary or somebody that was shipping those tapes off-site and you had to recall them. But once again, do your own testing here, whether it's with our product or even a competitive product. Understand how quickly you can get the data back, and if you're looking at moving from a competitive solution into Max Backup, do the test with the competitors. Put us side by side, test it for yourself. Understand whether you're making a move up here with things like the local speed vault and the various recovery options. Can we help you get the data back faster? Knowing that is the difference between a happy or an unhappy customer. Now, finally, convenience matters. The fact that I was able to remote in just from a system with a web browser, be it from a tablet, a laptop, over a cell or a Wi-Fi connection, I did that without installing software, without having to go back to my office or drive into my office. I didn't have to pull a technician. I did it after hours. Those kind of things really matter because you never know when the customer's going to have an outage and you're at a family reunion or you're on vacation. Well, you guys all realize this. Is there such thing as a vacation when you've got customers that have got issues? So all of those things are going to make it at least that much more enjoyable for you if you have to stop everything you're doing to help a customer get back into business. Now, our last scenario is around application recovery. So it's about 3:30 in the afternoon now. It's been a very busy day for us and for Bob and his environment. It's been 4 hours since we last worked with any of his devices, but I see his name come up on the caller display. And I'm assuming he's calling to thank me, but that's actually not the case. So I pick up the phone, and it's Mike. Mike's the guy on the left, the guy in the blue tie. And Mike is one of Bob's employees. He's the most technical of the bunch. He might be what you call the DBA or the stand-in for the DBA in that environment. So we've trained him at least to kick off a manual backup before he makes any changes or modifications to the SQL application or database. And that way we can ensure that we can at least roll back to a known good point if something were to go wrong. And that's the exact situation today. Mike's made some changes. He's updated the application, applied some patches, injected some transactions. He's done something, and he thinks he's corrupted his database. So what we want to do here is we want to roll back the database to a known prior good point, and we want to do that in the fastest, quickest, least intrusive method possible. Hopefully before Bob gets back into the office and wants to know why things aren't working properly. So with a SQL Server corruption, you've got a couple of choices. You could recover the entire database to another location, you could mount it, or you could just do an in-place restore and roll the database back to a known good point, and that's what we want to do today. So we're going to remote back into this environment. You should be getting used to this Hyper-V system now. So we'll open him up and get into the virtual machine. So once I'm into this system here, one of the first things I want to do is I want to stop the services. So because I want to do an in-place restore of Microsoft SQL, I need to stop the service for the SQL database. This will allow me to actually write to that database during the restore process. So in this case, it's actually SQL Express. So I'll go to the SQL Server service and stop this. Now, once this is done, I can do an in-place restore. And this would be the same process if you were restoring SharePoint or if you were recovering Exchange over top of the production information store or database. Now, once I've launched my backup manager, I'll go to the Restore tab. I'll select SQL on the left-hand side, and I'll pick an instance that I want to restore from. I'll go back an instance or so here to ensure it's a known good point. And then I can expand my selections for SQL. So these are application consistent backups of SQL, and there's 3 databases you can see here. I'm going to select all 3 databases, even though there's only one database that's giving me a problem. These databases are linked or intertwined, so I want to make sure I maintain referential integrity between the databases. I don't want one at 2 p.m. and the others at 1 p.m., if you will. So we're going to recover all those databases back to that known good point, and we'll kick that restore off. Now, it only takes a few bytes, kilobytes, megabytes of data to corrupt a database. Changes typically on a daily basis to your database, maybe 1 or 2%. That's kind of deltas that we're going to back up, and that's the kind of deltas I'm going to restore as well. So you can see here very quickly that data has been rolled back to where it was previously. I can exit the backup manager. I can start the SQL service. Now my next step would be either to start the application and check to see if it's working, or to reach back out to my DBA, in this case Mike, and let Mike know that we've recovered the data, rolled it back, let him go check the environment out, let him determine whether it's working properly or not. If he's still got issues, maybe I might want to go back to a prior point in time than this, or maybe work on doing a file and folder restore to recover the SQL application and roll it back to a prior point before we apply to service pack or what have you. But comparable scenario for you. Now, maybe it's going to be a larger database. Maybe you're not going to have a local speed vault in your situation, but the process and the steps are going to be identical. So, 2 principles that we saw here were around ensuring that we had the fastest possible recovery for Mike, and that's about moving less data and moving it from the fastest location. So, in-place restore with a delta restore gives us the moving less data, and then moving it from the fastest location is due to our local speed vault technology, that local mirror of our cloud storage, so I can restore at LAN speeds instead of WAN speeds. Now, does that mean I'm going to get restores at gigabit? Not necessarily, because we are still processing through, encrypting, decrypting, decompressing, and rehydrating that data. And then, of course, there's disk speeds, system speeds, and processing speeds. But still, local restores always going to be faster than cloud restores unless you're working over, say, a fiber connection or a gigabit connection. So to move less data, it's checking at a block level on the production machine to determine which portions of the data can stay and which portions have to be retrieved either from the cloud or from the local speed vault. All of the data restores that we do can take advantage of that delta recovery. It's a technique that we feel is very unique for us. It allows for our hybrid backup model. It allows us to have the data in the cloud even when you've got customers with limited bandwidth environments. Secondly, the fact that the data doesn't always have to come back from the cloud. It can come from this fastest location in the vault is great. We do this automatically. We don't specify that I want to restore from the cloud or from the vault. You just say restore, and we identify where the data resides, and we'll restore from one or the other location or both in cases where maybe they're not fully synchronized and some data exists offsite, some data exists locally. So ultimately, everything you've seen today is about having a platform that you can trust, something that you know that's simple, predictable, fast, that you can use to get your customer back up and running. You saw us fail over. You saw us fail back. We did rollback of a corrupted SQL database. We did some file recovery for Bob while we were away from our desk. All of those around building trust. So if you were to take that and then look back at some of the technology that makes us differentiate with others in the market, you're going to see, why we're in this space, why we're not selling to the end customer or the consumer. Our goal here is to provide a tool for the MSP to give a cloud or an offsite backup copy. The key technologies underneath that, things that differentiate us, are going to be our TrueDelta technology. TrueDelta, not just a single piece of technology, it's really an umbrella of technologies that help optimize and ensure that you can get cloud backup reliably and then still get the data back in a reasonable amount of time. And those technologies find changes faster, they send less data, they send fewer files. At the heart of that, we start with things like our Backup Accelerator. Backup Accelerator is designed on the backup side to shrink your backup window by by tracking and monitoring changes between successful backups. So we can monitor those large files, those large databases, those large applications, and know which pieces have changed, shrinking the backup window, by shrinking the backup window, I can run more frequent backups. I can have better recovery time and recovery point objectives for our customers. Data deduplication shrinks the data down by never sending the same data twice. We are a bidirectional client-side data deduplication product. So I can dedupe the data, only send it up to the wire once. When it's time to restore, I only send the data down once as well. That optimizes the process. In addition to deduping, I'm going to then compress the data and then finally optimize that data into cabinets. That means that the data, while broken into thousands or millions or tens of millions of little pieces, is then compressed and packaged so that it's still optimized for storage on an IP network, across an IP network, or storage on disk or cloud storage. Finally, we're going to wrap all of that data with an encryption layer based on a passphrase that you identify and an encryption layer that encryption level that you specify to ensure that you've got reliable, fast, secure data that can scale for tens or hundreds or thousands of devices. So, based on what you've seen here, if you were to show this to your customer, everybody's going to want 100% uptime. Everybody's going to want that standby server in the cloud, ready at a moment's notice, at least until you explain the cost. Now, when I say cost, I don't mean what we charge you. I mean what you're going to charge the customer to maintain and provide that service and that infrastructure. So in reality, every customer has got different needs. So if you look inside a customer, every machine can have a different need. The cost of downtime could be measured by the impact of that system being down. How many employees are going to need access to a device that's offline or failed? So a server being down could potentially impact every employee of a company, or worse yet, every customer of that company, whereas a laptop that is down may impact one or two users in the organization. Unless, of course, it's the CEO. So you can increase, you can set expectations based on the value or the importance of the device, and then you can build a plan around data protection and disaster recovery that matches the importance of that. So the cost of downtime, as that rises, the complexity and cost is going to increase, and you may go from a cloud backup for workstations and laptops up to something that's got a standby server or cloud continuity or disaster recovery testing even for those more business or mission critical systems. Don't overdo yourself, though. Build a set of packages, architecture them that are priced in a way that gives you a loss leader, something you're going to bundle with every solution. Give yourself an upsell, and then give yourself a premium, a gold, a platinum type package for that guy that needs everything. Where money's not an option, he just needs to make sure he's got his data back. Don't sell yourself short. Sell the disaster recovery. Sell the testing. Sell the fact that you're going to be here and there and available for the customer to walk him through his outage. Don't wait for the customer to call you with an outage before you start to determine what your SLA is for getting that data back. If you don't have documented, defined SLAs in place, then the assumption that your customer has following a crypto locker or a server loss is probably going to be different than the SLA that you're expecting to deliver. So set those, document those. If you haven't done it yet, hey, it's a great time to do that. Finally, as we wrap up here, it's about standardization. So why does standardization on a single platform matter to you guys? Well, standardization is just a fancy word for efficiency. It means that you've got one set of training, one console, simple, predictable results. It means that you can add more devices to an environment without adding more labor costs. Managing 10, 100, 1,000 devices should be roughly the same. So as a service provider, you should understand that adding more devices without adding more labor means more profitability. And that's what we want to deliver to you with this solution. So with that, we got just a couple minutes before the top of the hour. I want to thank you for your time and attention. I've got a quick 10-question test here that I'm going to kick off for you guys. If you guys can hang around to complete that. We'll give you a few minutes to do that. If there are questions or comments, feel free to drop those into the chat session of GoToTraining. I'd be happy to take some time to answer those. I'll sort through now and see if there were any questions during the session that we can answer. For those of you that may have joined late, we did record the session as well. So give me about 24 hours or so, and you can come back, and this recording will be available through the same link that you used to attend today. And that's great for you if you want to get some more information. Or, as always, you can reach out to your sales engineers or your account managers, and they can get you in touch with the right people to learn more about a given feature, function, or solution. So there were a couple questions in here. Let's see here. So there's a question about where is the data replicated after it hits your primary data center. So our data centers, so we've got data centers that exist in, like I said, 7 global geographies. And those data centers are going to have inside of them multiple storage nodes. Now, when we do our backups, I maintain those data distributed across storage nodes at one or more data centers, depending on what region you're working in. And that's going to be a primary backup copy. So you've got your primary copy, your production copy, if you will, on your physical server. You've got a primary backup copy, the first backup copy sitting out in our cloud. If you want a secondary recovery copy or redundancy copy, that's going to be your local speed vault that you are going to maintain at your customer location. And that would be a mirror of the cloud storage. That's going to give you the redundancy and the quick recovery. If you're looking for additional redundancy for your customer, that's when you'd stand up that recovery console, say at your data center at a customer secondary site, and that would be capable of maintaining the an offline copy of file and folder data, SQL data, Exchange, VM or VMware, VM, Hyper-V or VMware VMs, and that's going to provide or maintain the most recent updated version of the data that has been protected. Some questions do come up here about Server 2003 and the Windows XP. So those are also platforms that we do support. I didn't call them out specifically in my list today because of disaster recovery, but we do support XP and Server 2003 from a backup perspective. But when it comes to things like disaster recovery, virtualization, bare metal recovery, I'm afraid that those operating systems don't provide the right access to the right data through VSS for me to synthesize those machines for recovery. So we can do manual disaster recovery for those if you like, but I can't do an automated or virtual or bare metal recovery for those legacy operating systems. Hopefully you guys have started to migrate all of your customers off of those OSs. If you've not, and you've got to run, you're still kind of forced to run in those spaces, my recommendation would be to virtualize those environments. So once they're running inside of a hypervisor, I can back it up at a host level, and those host level backups are going to have full-blown capability to do host-to-host recovery or virtualization recovery. So that'll get and keep you protected. Okay, looks like we're about 75% submitted here. We'll give you guys just another minute or so to complete these tests, and then we can wrap up for the day. I want to thank everybody for your time and attention. If you have completed your test and you don't want to hang around for me to review the answers, that's fine. The Backup Academy and Recovery Academy as a whole is or was sending out certificates and t-shirts. I believe those are currently in the process of transition from the Logic Now brand over to the SolarWinds MSP brand. Hopefully that'll be resolved and taken care of shortly, but you may expect a short delay before you'll see those based on your completion. Okay, good deal. We are 100% submitted here, so I'm going to go ahead and close the test. And I'll bring this up here and see how you guys are doing. Average score, 90%. That's great. Question number 1 here, what recovery tool is most appropriate for providing business continuity? That was the recovery console that we went through at the beginning. All of the answers here, Backup Manager, Virtual Drive, Recovery Console, Bare Metal Recovery, all of those are great for providing restores, but it's that recovery console that's most appropriate for business continuity because it can be used for proactive recovery, meaning you can use it to create a VM behind the scenes in the event of an outage that you would boot, as opposed to waiting for the outage and then creating the VM. And that could shave hours off of the recovery time for your customer. Let's go see the end here. Everything else looking pretty good. Question number 7. 75% of you guys got this right. What technology aids recovery by transferring data at LAN speed instead of WAN speed? That's our local speed vault. That's that local storage copy of our backups, effectively a mirror of the cloud storage. And just having it on your local network allows you to recover at, you know, the 100 megabit, the gigabit types of speeds versus, you know, a 2, a 5, a 10 megabit download pipe that you might have for, you know, some of your customers' internet connections. Number 8, you must stop Microsoft SQL services to restore over top of the production database. That is true. That is true when you want to do a restore over top of a Delta restore, if you will. By stopping it, I can do that. If I did want to restore to an alternate location, I could do that, but that's going to recover the entire database, not just do a rollback of the existing database. And that concludes our session for the day. I want to thank you guys for your time and attention. I really appreciate you showing up. I would encourage you to check back probably within the next 60 to 90 days. We are in the process of revamping our Academy series with some additional modules and components, getting a little bit more detailed in some additional technologies like Exchange Granular Restore or individual file restore from a VMware or Hyper-V environment, and then getting deeper into the recovery console and the individual settings based on the recovery environments and so on. So check back within the next 60 to 90 days and see what new modules we've got. You may want to sign up for a additional session. Thank you, Mutlot, and have a great day, guys.